Welcome to this comprehensive guide on Room database. Room is a powerful SQLite abstraction layer designed specifically for Kotlin Android development. It provides a clean and efficient way to manage local data persistence in your Android applications. Throughout this tutorial, you will learn how to implement Room database from scratch, understand its core components, and master local database operations using modern Kotlin programming techniques. Room database is built on three fundamental components that work together seamlessly. First, we have the entity, which represents your database table definitions. Think of entities as the blueprint for how your data will be stored. Second, the data access object, or DAO, contains all the methods you need to interact with your database, such as inserting, querying, updating, and deleting data. Finally, the database class acts as the main holder and access point for your entire database. These three components form the foundation of every Room database implementation, and understanding how they work together is crucial for building robust Android applications. Before we can start using Room database, we need to add the necessary dependencies to our project. In your module-level build.gradle.kts file, you will need to include three key dependencies. First, add the Room runtime library, which provides the core functionality. Second, include Room KTX, which adds Kotlin extensions and Coroutines support for asynchronous operations. Finally, add the Room compiler using the KSP annotation processor, which generates the necessary code at compile time. Make sure to use a consistent version across all Room dependencies. The version 2.6.1 shown here is stable and widely used, but always check for the latest version in your projects. Now let's create our first entity. An entity is a data class that represents a table in your database. We use the @entity annotation to mark this class, and we can specify a custom table name using the table name parameter. In this example, we are creating a user table with three fields. The id field is marked with its primary key, and auto-generate equals true, which means Room will automatically generate unique identifiers for each new user. The name field uses the @column info annotation to specify a custom column name in the database, mapping it to user_name. The email field doesn't need any special annotation and will use its property name as the column name. This simple data class becomes a fully functional database table thanks to Room's annotation processing. The data access object, or DAO, is where we define all our database operations. A DAO must be either an interface or an abstract class, and we mark it with the @DAO annotation. Room provides convenient annotations for common operations. The @insert annotation automatically generates the code to insert a user into the database. Notice we are using a suspend function, which means this operation can be performed asynchronously using Kotlin coroutines. The @query annotation lets us write custom SQL queries. Here we are selecting all users from the users table and ordering them alphabetically. The return type is flow, which means this query will automatically emit new data whenever the database changes. The @delete annotation provides a simple way to remove entries from the database. Room handles all the complex SQL code generation behind the scenes. The database class ties everything together. It must be an abstract class that extends Room database. We use the @database annotation to configure it, specifying which entities are included using the entities parameter and setting the database version number. The version number is crucial for managing database migrations when your schema changes in future updates. Inside the class, we define abstract functions that return DAO instances. The companion object holds a volatile instance variable, which ensures thread-safe access to the database. The @volatile annotation guarantees that changes to this instance are immediately visible to all threads. This singleton pattern ensures that only one database instance exists throughout your application's lifetime, preventing conflicts and improving performance. To create an instance of your database, you use the room.databaseBuilder method. This method requires three parameters: the application context, the database class reference using the class.java syntax, and a string name for your database file. The fallback to destructive migration method is optional but useful during development. It tells Room to delete and recreate the database if a migration is not provided when the schema changes. However, be cautious with this in production as it will delete all user data. After building the database instance, you can access your DAO by calling the user DAO method. This DAO instance is what you will use throughout your application to perform all database operations. Performing database operations with Room is straightforward thanks to Kotlin Coroutines. To insert data, we launch a coroutine using viewModelScope.launch. Inside the coroutine, we create a new user object with the desired data. Notice we do not need to provide an id value because we set auto-generate to true in our entity definition. Room will automatically assign a unique id, then we simply call user-DAO.insert, passing our new user object. Because we marked this as a suspend function in our DAO, Room automatically handles the threading for us, ensuring the database operation does not block the main thread. This keeps your user interface responsive while data is being saved. One of Room's most powerful features is its integration with Kotlin Flow for reactive data observation. Here we are converting our flow from the DAO into a state flow using the state in operator. This requires 3 parameters. The scope determines the life cycle of the flow, typically viewModelScope for view models. The started parameter with sharing started dot, while subscribed ensures the flow is active only when there are active observers, which is efficient for resource management. The initial value parameter provides a default value, in this case an empty list, that is used until the first database query completes. With this setup, your user interface will automatically update whenever data in the database changes, without any manual refresh logic required. Let's review some essential best practices for working with Room database. First, always use suspend functions for all database write operations. This ensures your app remains responsive by keeping lengthy operations off the main thread. Second, leverage Flow for reactive data observation. This allows your user interface to automatically reflect database changes in real time, creating a smooth user experience. Third, implement proper migrations when your database schema changes. This prevents data loss during app updates and maintains data integrity. Finally, remember that all database operations, except those returning flow or live data, must be performed off the main thread. Room will throw an exception if you attempt to run queries on the main thread in production builds. Following these practices will help you build robust, performant Android applications with Room database.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.